Bismillahirrahmanirrahim. Last time we were discussing the kinetics of surface catalyzed reactions. So we have discussed two mechanisms. One is Langmuir-Henshaw-Root mechanisms and second is ER. So today we discuss some examples. For LH we have discussed, and for ER today we discuss the examples for ER mechanisms. So a reaction is degradation of rhodamine B dye catalyzed by degradation of rhodamine B dye catalyzed by silver cobalt catalyst AgCO3O4 catalyst. Rhodamine B degradation in the presence of oxygen and AgCO3O4, it gives degradation products. So the kinetics of this reaction has been described in terms of Eddy-Riddle mechanisms. Kinetics has been described in terms of ER mechanisms. So according to ER mechanism, one of the reactant in dissolved form while other react in fluid phase. So according to studies, it has been proposed that oxygen in this reaction react in adsorbed form and rhodamine B, it reacts in fluid phase. That is RHB in liquid and O2 in the form adsorbed and give degradation product. So rate of reactions R is equal to Kr, O oxygen adsorbed and concentration of RHB. R rate would be equal to rate Kr theta O2 and RHB. This reaction has been studied in beaker open to atmosphere. This is reaction mixture, so it is open to atmosphere. Hence, the pressure of oxygen is constant. So therefore, इसको हम combine कर लेते हैं. Then rate is equal to K apparent and concentration of RHB. So this is a simple first order equations. That is log RHB naught and RHB T is equal to K apparent and T. So you can find this article in Chinese Journal of Chemical Engineering. It is published in Chinese Journal of Chemical Engineering and उसका year है 2018 और 16 number volume है and page number is 1264 to 1269. तो ये एक एग्जाम्पल है for ER mechanism. Similarly, और भी कुछ examples हैं. For example, another reaction is degradation of methyl orange by SAN catalyst. Degradation of methyl orange by AgCO3O4. MO methyl orange in the presence of oxygen gives degradation product. तो इस रिएक्शन को भी डिस्क्राइब किया गया है in terms of ER mechanisms. Has been described in terms of ER. So oxygen, it reacts in adsorbed form, while MO, it reacts in fluid phase. So MO in liquid and oxygen in adsorb and gives product. So rate would be equal to, rate is equal to Kr oxygen adsorb and MO in fluid phase. This square bracket represents the concentration are Kr, theta O2 and MO. So rate expression in terms of Illy-radial mechanisms. Again, the pressure of oxygen is constant, so we get R is equal to K apparent and MO. Again, this is a simple first order equations. If we rearrange and integrate, we get log MO naught. This MO naught is the initial concentration of the methyl orange. इससे पहले वाले एग्जांपल में रोडामिन B naught था, that is the concentration at initial concentration of the dye, and MOT is the concentration at different time interval is equal to KAP and T. So this is another example and it has been published. You can get it in Green Processing and Synthesis. Green Processing and Synthesis. It is published in 2019. Our volume number 8 and page number is 382 to 390. 382 to 390. इसी तरह और एग्जाम्पल भी है. आप इसमें आप खुद इसमें से देख लीजिए वो कौन से एग्जाम्पल है और क्या मैकेनिज्म यूज किया गया है. ग्रीन प्रोसेसिंग एंड सिंथेसिस 2019 और वॉल्यूम नंबर 8 और पेज नंबर 659 to 666. ये आपको स्टडी कर लें. आप देख लें कि इसमें कौन से रिएक्शन को स्टडी किया गया है और उसके मैकेनिज्म क्या है. सिमिलरली आप ये भी देख लें, बुलेटिन ऑफ केमिकल सोसाइटी ऑफ इथियोपिया. ये 2020 में और इसका वॉल्यूम नंबर है 34 और पेज नंबर है 123 to 134. ये दो रिसर्च आर्टिकल आप खुद देख लेंगे और इसमें आप देख लें कि कौन सी रिएक्शंस को स्टडी किया गया है और उसके मैकेनिज्म क्या है. रिएक्शन है, फॉर एग्जांपल अगर आपको क्वेश्चन दे दिया जाए रिएक्शन CO gas phase and oxygen in gas phase gives CO2 in gas phase. It has been experimentally found that rate of this reaction is proportional to pressure of oxygen and inversely proportional to pressure of carbon monoxide. ये experimentally proved है, it has been proved experimentally that rate of reaction is proportional to pressure of oxygen while it is inversely proportional to pressure of carbon monoxide for this reaction. तो इसके लिए ये अब कैसे प्रूव करेंगे, इसके लिए प्रपोज मैकेनिज्म क्या होना चाहिए, इसके लिए क्या करना चाहिए? अगर हम इस रिएक्शन को काइनेटिक्स को डिस्कस कर ले, डिस्क्राइब कर ले इन टर्म्स ऑफ लैंगमर-हेंशल-वुंड मैकेनिज्म्स, देन वी कैन एक्सप्लेन this relationship using the LH mechanisms. It can be explained according to LH mechanisms. LH mechanisms क्या है? ये पहले ऑक्सीजन in the gas phase move toward the surface and it is absorbed. Similarly, carbon monoxide in the gas phase move toward the surface and it is adsorbed. Then oxygen in adsorbed form and carbon monoxide in adsorbed form reacts and gives carbon dioxide in adsorbed form and carbon dioxide in adsorbed, then carbon dioxide in gaseous phase. So this is the chemical reaction step. So according to these mechanisms, the rate would be equal to, rate is proportional to oxygen in adsorbed and carbon monoxide in adsorbed form, or it is proportional to theta of oxygen and theta of CO, or rate is equal to Kr theta of oxygen and theta of CO. So using the Langmuir adsorption isotherms, we can get as rate is equal to Kr A P of O2 and B P of CO divided by 1 plus A P of O2 plus B P of CO. ये इक्वेशन हम फिल कर सकते हैं. Considering the Langmuir adsorption isotherms, competitive Langmuir adsorption isotherms, we get these equations. अब अगर हम इन दोनों को देख लें, as oxygen is a homonuclear and non-polar molecule. Oxygen, this is homonuclear and non-polar. Our carbon monoxide, it is heteronuclear and it is polar. And polar. So therefore, carbon monoxide adsorbs strongly, while oxygen adsorbs weakly. Carbon monoxide adsorbs strongly, while oxygen adsorbs weakly. क्या मतलब? Adsorption coefficient of carbon monoxide, that is B, is much greater than 1, while absorption coefficient of oxygen A is much smaller than 1 because it is weakly absorbed. So under these conditions, it shows that the absorption coefficient B is much smaller than A, much greater than A. B is much greater than A. तो इस केस में इसको हम इग्नोर कर सकते हैं, इस टर्म को इग्नोर करेंगे because this is much smaller in comparison to B. In other words, 1 plus A P of O2 and plus B P of CO is equal to B P of CO. अगर ये हम इसमें पुट कर लेते हैं, then we get as rate is equal to Kr A P of O2 B P of CO divided by B P CO and square. तो ये एक इसमें से कट जाएगा, तो rate is equal to Kr A P of O2 divided by P of CO. इन सारे कांस्टेंट को अगर हम निकाल दें, then rate is equal to P of O2 and P of CO. This is the same equation. So this relationship can be explained in terms of linear action mechanism. So this is all about the kinetics. Now, uses of catalysis. What is the application of catalysis? Next, we discuss the application or uses of catalysis. Uses of catalysis in industry. Mostly it is used in industry. More than 90% mostly used in industries. More than 90% of the reaction in industries are catalytic reactions. It means it is used in industries. For example, कुछ example लेते हैं. Number first, fertilizer industry. Fertilizer industry, that is the synthesis of urea. Synthesis of urea. So first step of urea synthesis is the catalytic synthesis of ammonia. The first step of urea synthesis is the catalytic synthesis of ammonia. And this process is called as Haber process. So reaction is nitrogen in gas phase and hydrogen in gas phase. It gives ammonia and H3 in gas phase. And catalyst used in this reaction is iron. So one of the use of the catalyst in industry. Similarly, another example is the production of carbon dioxide on large scale. Production of carbon dioxide. So most of the refreshing drinks, they contain carbon dioxide. These are carbonated. So carbon dioxide on large scale is produced by different methods. Carbon dioxide on large scale is produced by different methods. One of them is the catalytic oxidation of carbon monoxide. Catalytic oxidations of CO. So CO and oxygen, it gives carbon dioxide using a solid catalyst. Let's suppose platinum. So this is another example of usage of catalysis in industry. Similarly, production of sulfuric acid. H2SO4. H2SO4, this is a product which is used in different industries, widely used in industries. H2SO4, it is widely used in industry as well as in educational institutions, academic institutions. Academic and research institutions. So basic step of the synthesis of sulfuric acid involves the catalytic oxidation of sulfur dioxide. Basic step of synthesis of H2SO4 involve the catalytic oxidations of SO2 and oxygen is phase in the presence of the catalyst, it gives SO3. Catalyst in this reaction most commonly uses atria, Y2O3, atria catalyst. Similarly, hydrogenations, third number. हाइड्रोजनेशन किसे यूज करते हैं? Heterogeneous catalytic reaction is used to convert oil into vegetable ghee in hydrogenation process. Oil is converted into ghee by catalytic reactions, catalytic hydrogenation reactions, जिसमें से अनसैचुरेटेड हाइड्रोकार्बन्स को सैचुरेटेड हाइड्रोकार्बन्स या डेरिवेटिव्स में कन्वर्ट करते हैं. अनसैचुरेटेड हाइड्रोकार्बन्स को कन्वर्ट करते हैं सैचुरेटेड हाइड्रोकार्बन्स यूजिंग द कैटलिस्ट. फॉर एग्जांपल, मोस्ट कॉमन एग्जांपल अगर हम ले लेते हैं C18 गैस फेज रिएक्शन को और हाइड्रोजन्स, इट गिव्स ईथेन. निकल कैटलिस्ट की मौजूदगी में. Similarly, petroleum reforming में it is used in petroleum industry. Catalysts are used in petroleum industry and petroleum reforming. Petroleum reforming. Petroleum reforming में क्या करते हैं? In this process, this is the process used to convert the long chain hydrocarbon into branched chain hydrocarbons. This process is used to convert long chain hydrocarbons into branched chain hydrocarbons. Long chain or linear chain hydrocarbons into branched chain hydrocarbons in the presence of catalyst. Branched chain hydrocarbons are the reforming increases the burning capacity of the fuel. Reforming increases the burning capacity of fuel. For example, N-octane is reformed in the presence of catalyst. Different catalysts can be used for this process to branched chain hydrocarbon 2,2,3 trimethyl pentane 2,2,3 trimethyl pentane, a high quality fuel, a high octane number. So these are some uses of catalysis in industry. और भी बहुत से हैं. For example, cracking of petroleum. इसी तरह redox reaction में भी यूज करते हैं. Production of hydrogen gas on large scale. Production of water gas. And hydrogen gas on large scale. So different industries में catalysis को use करते हैं. तो next पर हम दूसरे टॉपिक के साथ डिस्कस करेंगे. आज के लिए इतना काफ़ी है.